This lesson is on the solubility rules, and we will specifically be doing the solubility rules for ionic compounds in water. So you can have polar compounds that dissolve in water, and then you can have compounds that dissolve in other solvents, but we're specifically doing ionic compounds in water. So for example, if we have some table salt, that is the compound sodium, Na, chloride, Cl. So if we take some sodium chloride and put it in water, it dissolves in the water, so that we say that the sodium chloride is soluble in the water. So we can represent the dissolving process as NaCl. Solid, when it is put in water, becomes NaCl. Aqueous, Aq. Now, if we take maybe some chalk dust, well, this does not dissolve, or not to any appreciable extent. Does not dissolve. So we would say that our chalk dust, oops, I forgot to give you the formula. So this is usually calcium carbonate, CaCO3. It does not dissolve, so we would say that it is insoluble in water. And for AP chemistry, the most important rules for ionic compounds in water in terms of solubility is that all sodium, potassium, ammonium, and nitrate compounds that have these ions are soluble. That's the most important thing for us to remember. Sodium, ammonium, potassium, nitrate, they are soluble. But now we're going to go ahead and look at the solubility rules chart. So you should have that out. If you don't, you might want to get that. And we'll look at that. And there we go. So here are our solubility rules. So if we look at the very first rule, we see the sodium, the potassium, and the ammonium. These are all soluble. So this is basically all our group 1 ions and ammonium. So any ionic compound that has these ions is soluble. So for example, if we have, whoops, where did my pen go? Where did my pen go? Oh, annotate. Sorry, guys. Oh my goodness. So for example, if we have lithium chloride, then we would expect that this would dissolve in water because it has a lithium ion. If we had NH4Br, ammonium bromide, again, it's got ammonium, so we would expect that ammonium bromide would dissolve in water. Our second group of compounds, now we're looking at the anion. Up here we looked at the cation. So for our anions, the nitrate ion, the acetate ion, and the perchlorate ion, if any compound has either of these in it, then we would expect that that compound is soluble. So we could have magnesium nitrate, and we would expect that to be soluble, or we could have sodium acetate. Oops, how did that happen? Sodium acetate. Or we could even have something like copper, Roman numeral 2 perchlorate. And we would expect all of these to be soluble because they have nitrate, acetate, or perchlorate in them. Now we're going to start getting into, though, some exceptions. So if we have the anions, chloride, bromide, or iodide, now usually compounds with those ions are soluble, but now we start to have exceptions. So if we have the silver ion with either chloride, bromide, or iodide, it is insoluble. So we could have magnesium chloride. That's not an exception, so we would expect this to be soluble. But if we have silver chloride, that's an exception, so this is insoluble. Same thing if we had lead, Roman numeral 2 chloride. Usually chlorides are soluble, but lead is not, so this would be insoluble. But if I had copper, copper, Roman numeral 2 chloride, copper is not an exception, so it is soluble. We would predict it to be soluble. All right. So if we look at sulfate, now we have the same exception here with the lead. Silver evidently is soluble. It's not an exception now, but barium is an exception. So if we have barium sulfate, then this would be insoluble. But if we had magnesium sulfate, so it's not an exception, compounds of sulfate, generally soluble, so this would be soluble. So that is for the soluble part of the solubility rules. So now we're going to look at when our rule is that most of the compounds are insoluble. Let me move this, whoops, down a little bit. Oh, hold on, guys. I'm still getting used to using this pen. Okay. All right. So now we're looking at when we have compounds that are not soluble. They don't dissolve in water. So carbonates, phosphates, sulfides, chromates, fluorides. Now, the exception to this is our group 1. This supersedes everything, these two. The group 1, ammonium, the nitrate, acetates, and perchlorates, they're always soluble. Doesn't matter what they're with. If we have carbonates, phosphates, sulfides, chromates, and fluorides, then we have to look at what they're with. If they're with group 1, don't worry about it. They are soluble. If they're with anything else, they are insoluble. So if we have magnesium carbonate, it's a carbonate. It's not in our group 1 or ammonium list, so this would be insoluble. But if we had potassium carbonate, it's a carbonate. However, it's a group 1 ion, the potassium ion, so this is soluble. And now same thing here, compounds with OH minus hydroxides. So hydroxides are usually insoluble unless they have group 1 ions, the ammonium ion, and the heavier group 2 cations, strontium and barium. In calcium and magnesium, hydroxides are somewhat soluble, but we're not going to worry about the somewhat solubles at this point. So this is how you use this chart. Up here, they're saying what is soluble, the exceptions are not soluble. Here, they're saying the compounds that are not soluble and the exceptions that make them soluble. Okay, so we're going to go back to the whiteboard and then we will do some examples here. Okay, whiteboard. As soon as I figure out how to do it, oh yeah, I got to go to this. Mouse. All right, so we're back at the whiteboard. But remember, this is the most important when you see these. Okay, so now we're just going to do a bunch of examples, and I'll write down the formula, and then we'll figure out if it's soluble or not soluble in water. So our first one, FeOH3. So this is iron, Roman numeral 3 hydroxide. And now we have to figure out if it's soluble or not. So we see that we have a hydroxide. So if we check our chart, hydroxides are usually insoluble. The exceptions are group 1 ammonium. This is not an exception. So this would be insoluble. It would not dissolve to any appreciable extent in water. Let's look at magnesium chromate. All right, so magnesium is group 2. So we look at our anion, the chromate, and we check our chart. And we find chromate in the category of compounds that are insoluble. So chromates are usually insoluble unless they're with group 1. Magnesium is not in group 1. So then this follows the insoluble rules and is insoluble. Let's look at lead, Roman numeral 2, iodide, PbI2. So we look at the iodide, and that is in the top part. So iodides are usually soluble, but the lead Roman numeral 2 ion is an exception. So this then is insoluble. All right, let's look at silver nitrate, AgNO3. So we look at the nitrate, and that is one of our rules. Nitrate compounds are always soluble. That's it. Case closed. This is soluble. Doesn't matter what the cation is. If we have a nitrate, it is soluble. All right, let's look at potassium phosphate. So here we see potassium. Potassium is our first rule. Potassium compounds are always soluble. It doesn't matter what cation they are with. You see potassium, it is soluble. Let's do Cu, copper, Roman numeral 2 carbonate. All right, so copper's not, usually mentioned on that solubility rules chart, so we just look at the carbonate. Carbonate's in the second section, so carbonates are usually insoluble. We check, is the copper an exception? No. Group 1, ammonium is an exception. It's not an exception, so this would be insoluble. We would predict that it would not dissolve in water, at least to any appreciable extent. Let's look at zinc acetate. All right, so we don't see zinc anywhere in our solubility rules, so we look at our anion, the acetate, and the acetate is in the section that is always soluble. Acetate's always soluble, so we don't care what the acetate is with. Acetate compounds are soluble. Let's look at zinc phosphate. Okay, so again, we have to look at the anion, and phosphate is in the second group. The insolubles, zinc is not an exception. This is insoluble. All right, so I think you have the idea now. So I'm going to put up a whole bunch of compounds, and you can copy them down and then pause the video. And then when you're finished, come back and we'll see how well you did. Okay. All right, so let's start with this. Silver bromide. So you're just going to say whether they would be soluble or insoluble in water. Calcium nitrate. Let's do some more. So Cu for copper. All right. So as I said, go ahead, pause the video, and label each as soluble or insoluble. It might also be a good idea to name the compounds just for some extra practice. Okay, so go ahead, pause it, and then come back. All right, so you're back, and here we go. So silver bromide. So bromides are usually soluble, except silver is an exception. So this we would classify as insoluble. For calcium nitrate, nitrates are always soluble. Case closed. Don't have to think about anything else. It's soluble. Hydroxides, most of them are insoluble except group 1 cations. So then this becomes soluble. If you see lithium, you know it's soluble. Here we have chromium, Roman numeral 3, sulfide. Sulfides are in the insoluble category, and chromium's not an exception, so insoluble for the sulfide. For sodium sulfide, sulfides are usually insoluble, as we just mentioned. However, group 1 cations supersede that. They are always soluble. Rubidium fluoride, rubidium is a group 1 cation, always soluble. Doesn't matter what it's with. Okay, back up here. This one's a little tricky, and I might go into this later. So this is a chloride. Chlorides are usually soluble. So now we have to check the cation. The exceptions are the silver ion, the mercury Roman numeral 1 ion, and the lead Roman numeral 2 ion. Mercury Roman numeral 2, Hg2+, is not an exception. This is soluble. For barium sulfate, so we look at sulfates, they are usually soluble, but barium is an exception. So this is insoluble. soluble because the barium ion is an exception. Right? Aluminum perchlorate. Perchlorates are always soluble. Doesn't matter what the cation is. If it's perchlorate, it's soluble. Sodium hydroxide. Hydroxides are usually not soluble, except when they're with group 1 cations. All sodium compounds are soluble, so the sodium supersedes the hydroxide, so that this is soluble. Copper Roman numeral 2 hydroxide. Hydroxides are usually not soluble. Copper is not a group 1, so this is insoluble. Lead sulfate. So we check the sulfate, and sulfates are usually soluble, but lead is an exception. So according to our chart, this would be insoluble. Coming up to barium hydroxide. Hydroxides are usually insoluble except group 1 and barium and strontium. So this is soluble. So it's those group 2 at the bottom of the periodic table that are soluble. Potassium sulfide. Sulfides are usually not soluble, but we don't even have to look at that. All we have to look at is the potassium. As soon as we see potassium ions, we know that our compound is soluble. And then iron Roman numeral 3 sulfide. Sulfides are usually insoluble. Iron is not an exception, so this would be categorized as insoluble. All right, and last, I'm just going to go over mercury. So we have mercury, the metal. Just plain old mercury. We have the mercury, Roman numeral 1 ion, and the mercury, Roman numeral 2 ion. The symbol for mercury is just Hg. The mercury, Roman numeral 1 ion, this is an exception. It's the only ion I know that is like this. It is Hg2 with a 2+ charge. What this is a mercury Roman numeral 1 covalently bonded to another mercury Roman numeral 1. So this whole thing has 2 mercuries. That's where this 2 comes from. And +1 and +1 is +2. So this Roman numeral 1 refers to the charge of each mercury. So this is a polyatomic ion. Mercury Roman numeral 2, that's just normal. It's just Hg with a 2+ charge. So Hg, this is not soluble in water. Liquid mercury, that's a metal. Metals are not soluble in water. So mercury is insoluble. The mercury 1 ion, if we have the compound Hg2Cl2, mercury Roman numeral 1 chloride. Chlorides are usually soluble, but this mercury Roman numeral 1 is an exception. So this compound is insoluble in water. If we have mercury Roman numeral 2 chloride, HgCl2, so this has 2 mercuries for 2 chlorides. This has 1 mercury for 2 chlorides. Chlorides are usually soluble. This is not an exception. This compound is soluble. So if you were to swallow some liquid mercury, it won't be a good idea but it wouldn't be absorbed very well because it's not soluble. Most of it would just pass right through you. With the mercury Roman numeral 1, it doesn't dissolve well. So if you ingested some of this, it would mostly go right through you. This one, however, it's soluble. That's going to dissolve in your body, and this is highly toxic. So there's a big difference between mercury Roman numeral 1 and mercury Roman numeral 2. And the way I remember which one of these is soluble and which is insoluble is that I know a metal by itself is not soluble, and mercury Roman numeral 1 is closer to mercury than mercury Roman numeral 2. So I remember it this way. Plain mercury, mercury 1 are both insoluble, and mercury Roman numeral 2 is soluble. All right, and we'll be using this in our next lesson on how to predict products for precipitation double replacement reactions.